Hello, my name's Andy Connell and you're watching a screencast on software testing. Inside the screencast we're specifically going to be looking at how test data might be created. Now in the previous screencast we saw how test cases, the individual tests, might be classified as being perhaps black box tests, white box tests, or experience-based tests. Taking each one of these in sequence, we'll start with black box testing. Black box testing, which is also known as specification-based testing, is more concerned about what outputs you get for any given input. It's not so concerned about how the data is generated, it's more concerned about the fact that the answer is correct. Black box testing can be split down into 5 different classifications of test. First off, we've got the idea of equivalence partitioning. We have boundary value analysis, we have decision tables, we have use case testing, and we also have state transition testing. So, taking each one of these in sequence, let's have a brief overview of what they mean. Equivalence partitioning is about recognizing when one data value is pretty damn similar to another one. For instance, if on a surname field I entered my surname Connell, then I wouldn't have to enter other names like Smith and Jones, because they're pretty similar to Connell. Alpha characters, no spaces, no special characters. So it helps cut down on testing by reducing the number of boring, meaningless, repetitive tests we have to do. The second classification we looked at was boundary value analysis. Boundary values are all about testing just this side of what is valid and what is invalid. For instance, if we had an acceptable age range, perhaps for a sports team of between the ages of 18 to 40, then we would test the ages 17, 18 and 19, the lower boundary, and we might test the upper boundary of 39, 40 and 41. It's a fact that errors tend to accumulate around boundaries and interfaces, so it's a good way of finding some data for our test cases. The third one we looked at was decision tables. Decision tables are about recognizing the fact that there are certain rules inside a business which are valid and produce valid outcomes, and there are certain rules which are invalid, produce invalid outcomes. Perhaps the easiest way to see it would be with an example. So here is an example of the rules around what is to be done when a printer is non-functional. We have the rules running along the top row, rules 1 through to 8. We have 3 conditions which might exist: not printing, red light flashing, printer unrecognized statement. And we have 5 things which we might want to check. So given a given set of conditions, this is what you do. This can be used to help create a test case, or a series of test cases, in this case at least 8. Moving on from decision tables, we're going to go and look at use case. Use case is very similar to experience-based testing in as much as it's a way of creating a business scenario which reflects what the business actually does in the real world, and then we take that scenario and we create a test case around it. The example given here is teachers might create courses, students might study courses and take exams. So it's recognizing the user, it's recognizing the kind of function that they want the system for, and then we create test cases around that function. The final one we looked at was called state transition. State transition is recognizing the fact that certain entities can exist in different states, and they will move between those states in response to events, things that happen to them. So, again, if we look at an example of a state transition diagram, we might think about the states in which perhaps an order sits when you buy a burger at McDonald's. You give the person behind the counter the order is unactioned. Nothing's going to happen to that order until you pay for it, so you make your payment. Another event. Having made the payment, the operative then assembles the order and gives it to you. At the point of giving it to you, that's another event. The order is effectively closed. So this is looking at a state transition in terms of a table, but we could do it diagrammatically, exactly the same information, an unactioned order, actioned order, paid order, closed order, with the event and the person who is initiating that event described on it. Now we move on to white box testing. White box testing is also known as structure-based testing, and this is concerned about how the answer is derived, the efficiency of the code, the standards being used, the coverage which you get. So if we think about white box testing, we're going to think about three different types of test. First, flowcharts. Secondly, control flow graphs. And then finally, we're going to look at statement testing and statement coverage. Starting with flowcharts. Flowcharts are a visual representation of the program code. So here's a simple flowchart. We have a process, we make a decision out of which the answer might be yes or no, and then depending on whether the yes or no is answered, we might conclude, or we might just go around and do the process again. The second type of white box test, which we'll need to consider, is a control flow graph. This is really just thinking about the program in terms of the decisions that the program makes. Very similar to a flowchart, it uses the word flow, but perhaps it has a different representation. Here are three different types of programming construct. We have an if this, do this, else do something else. We have do while, and we have repeat until. And they have different kinds of diagram which helps explain what is going on inside the program. And it will allow us to test the validity of the various states in which the entities sit. Finally, we have the concept of statement testing and coverage. Statement testing and coverage is really trying to establish that every element of the system is usable. We don't have any cul-de-sacs perhaps from which we cannot get out of. We don't have any code which perhaps is never executed. So it's a dry running of the program. So in some respects it might be considered to be a static type of test. The final category of test we looked at, having looked at black box testing and white box testing, was experience-based testing. Experience-based testing relies on the users to use their experience to help create realistic scenarios. They might try and use their past experience of where errors used to happen, perhaps inside the old system, or awkward cases perhaps, or even random cases. Anything which can help improve the robustness, the fitness of purpose for the system is useful. Generally run inside perhaps user acceptance testing, UAT testing. Now we've very briefly covered a whole range of different techniques here. We have covered none of them in sufficient detail to fully explain them, other than to give a brief description. Exactly what type of test is required really depends on the types of system that you've got, how risky it is, how prone to failure it is, what the downside of that failure is, how much money you've got, a whole series of factors. This concludes this screencast. Thank you for watching.